Welcome to the lectures in the properties of reservoir rocks.
The fifth lecture. Saturation.
Your suggestions and comments are welcome via email or through one of the two blogs.
Saturation.
Introduction. The pore space of a petroleum reservoir is never filled completely with hydrocarbons. Water is always present in the liquid state, and the hydrocarbons can exist in one or more states, gas or liquid. Porosity represents the maximum capacity of a reservoir rock to store fluids. Fluid saturation or pore space saturation actually measures how is that storage capacity, or pore space distributed among the three typical reservoir fluid phases: gas, oil, and water. In a typical oil field, the pore space is filled with 2 or 3 types of fluids: water plus oil, water plus gas, water plus oil plus gas. The volume of a fluid in a reservoir rarely remains constant. Water can enter the reservoir either naturally from an adjacent aquifer or artificially by water injection. Oil volume decreases with oil production and the replacement of oil by another fluid such as water. Gas volume could increase with gas injection into the reservoir or as gas evolves naturally from the oil when the pressure drops. When the hydrocarbon invasion took place as part of the migration process, gas, oil, and water distributed in the pore spaces of the reservoir by a balance between the gravitational and capillary forces. As shown in figure, the less dense hydrocarbon phases, gas and oil, migrated to the structurally high part of the reservoir rock due to gravity. An accurate determination of water saturation is of a considerable importance in the oil and gas fields, especially in determination of initial hydrocarbons in place. In order to determine the quantity of hydrocarbons accumulated in a porous rock formation, it is necessary to determine the individual fluid phase saturation, i.e., gas, oil, and water.
Fluid saturation definition.
The fluid saturation is defined as the ratio between volume filled with fluid to the total pore volume. In other words, saturation is defined as that fraction, or percent, of the pore volume occupied by a particular fluid, oil, gas, or water. This property is expressed mathematically by the following relationship. Applying the previous mathematical concept of saturation to each reservoir fluid gives all saturation values are based on pore volume and not on the gross reservoir volume. The saturation of each individual phase ranges between 0 to 100%. By definition, the sum of the saturations is 100%, therefore, the fluids in most reservoirs are believed to have reached a state of equilibrium and, therefore, will have become separated according to their density, i.e., oil overlain by gas and underlain by water.
Example:
Fluid saturation types.
Critical oil saturation. For the oil phase to flow, the saturation of the oil must exceed a certain value, which is termed critical oil saturation. At this particular saturation, the oil remains in the pores and, for all practical purposes, will not flow. Critical water saturation. The critical water saturation, carnate water saturation, and irreducible water saturation are defined the maximum water saturation at which the water phase will remain immobile. Critical oil saturation. Critical water saturation. Residual oil saturation. During the displacing process of the crude oil system from the porous media, there will be some remaining oil left that is quantitatively characterized by a saturation value that is larger than the critical oil saturation. This saturation value is called the residual oil saturation. Movable oil saturation. Movable oil saturation _ is another saturation of interest and is defined as the fraction of pore volume occupied by movable oil, as expressed by the following equation. Critical gas saturation. Hydrocarbon fluids in petroleum reservoir normally exist at high pressure and high temperature conditions. Due to this high pressure, gas is normally dissolved in the oil phase. As the reservoir pressure declines below the bubble point pressure, gas evolves from the oil phase, and consequently, the saturation of the gas increases as the reservoir pressure declines. The gas phase remains immobile until its saturation exceeds a certain saturation, called critical gas saturation, above which gas begins to move.
Average saturation.
Proper averaging of saturation data requires that the saturation values be weighted by both the interval thickness H and interval porosity. The average saturation of each reservoir fluid is calculated from the following equations.
Measurement of saturation.
Fluid saturation in reservoir rocks can be determined by basically two different approaches, direct and indirect. Direct methods. Direct measurement methods rely simply on the removal of all liquids by evaporation or extraction from a core sample, and determining their individual volumes. Indirect methods. Fluid saturations can also be estimated through indirect methods such as capillary pressure, rock resistivity, and well logging. Direct methods. Retort distillation. The rock sample is placed in the retort. Heat the rock sample at approximately 400 Fahrenheit for 20 minutes to 1 hour, resulting in the vaporization of oil and water. Dean-Stark extraction.
Indirect methods. Fluid saturations can also be estimated through indirect methods such as measurement of rock resistivity and well logging.
Fluid saturations can also be estimated through indirect methods such as measurement of rock resistivity and well logging. Fluid saturations can also be estimated through indirect methods such as measurement of rock resistivity and well logging. Thank you for being there for me and offering your support.